Ladies and gentlemen, friends all, tēnā koutou katoa. Firstly, thank you to Larry, Andrew and Barry particularly for that very complete introduction. As a graduate of the University of Canterbury Engineering School in 1967, just at the end of the Hopkins era, and his most noteworthy time as our Dean, it is a real honour to be here. And by the way, I think it would be appropriate to mention Barry's great contribution to this university as the chairman of the University Foundation. I'm told he's revolutionised the investment structure of that foundation. Great work. It is with great pleasure and not a little trepidation, given my far more illustrious predecessors, as Andrew pointed out, I certainly don't feel I fit into that group of people, that I'm here this evening to talk about the benefits and challenges of planning for and delivering infrastructure, such a vital component underpinning, another good engineering word, the economies and functioning of societies of all countries. To quote the chairman of the Australian Productivity Commission, infrastructure is the platform on which societies and firms construct the future. Tonight I will break my presentation up into 6 sections as illustrated up on the screen. I won't go through those, we'll come to them as we go. So, by way of introduction, I have spent the bulk of my career working in major project and infrastructure from shortly after I returned to New Zealand, having completed my PhD at Stanford, for what I thought was to be a career in environmental and water planning, and have continued to work in the infrastructure sector right up to this very day, much as I probably should have retired, but as I provide advice and work on infrastructures both in Australia and here in New Zealand. Huntly Power Station is there because it was the first really big project I worked on, and I actually opened up that site with a supervisor. We had a bolt cutter and clipped the fence and off we went. But also it's notable to me because my brother John, who passed away recently, was the primary architect in designing what is, I think, one of the most architected large power stations I've seen. My infrastructure journey started with a meeting with Bill Duncan. At that time he was the Assistant Commissioner of Works, I think, and later the Commissioner, a leading engineer and a very pragmatic man. Not long after I got back to Wellington, he called me in to congratulate me, but suggested that while I was a bright young man, I should go out into a construction site for a while to knock the edges off. A bit dismayed, I said, "How long?" He said, "A couple of years." Gee whiz, I thought, that's not in the plan. Every engineer has a plan, you know. Anyhow, of course, off I went to the New Plymouth Power Station project, and a year later moved north to begin the site establishment at Huntly. And by the way, I feel quite proud that Bill Duncan, the man who set me on my infrastructure career, also gave this lecture a number of years ago. Lo and behold, I enjoyed the work so much, the immediate results and direct feedback, the sense of daily achievement and the delivery of goals, that I never went back to pursue the more esoteric and perhaps more socially aware engineering career that I had set as my original goal. As an aside, one of life's lessons is to go hard at opportunities when they arise, even when they're not planned. Another insight from those early days is that engineers, much as I like to kid you otherwise, are actually enablers. The task being to plan, to provide the design and material, and let the real builders, the superintendents, the foremen, the skilled workers get on and do the actual job. A final point to note is that one has obviously been around too long when the early projects like Huntly have been or are being mothballed. But before we go too far, it is necessary to provide some boundaries or definition of my topic tonight. The generic term infrastructure covers an incredibly wide range of assets or enablers for society. The traditional elements of infrastructure are the very evident, mostly civil or mechanical structures such as roads, bridges, tunnels, railways, power stations, hydrothermal, geothermal, airports, ports and so forth. In another category, there are the social infrastructure projects, hospitals, schools, prisons, public housing and so on. Also included projects which provide work and living spaces, public buildings, offices, apartment blocks, and so on. Boundaries obviously overlap. Enabling infrastructure, my term, covers assets such as water and gas pipelines, electrical transmission lines, high-speed communication, and so forth. The internet is probably the most ubiquitous and most regularly used enabling infrastructure, critical for virtually all of us for daily communications, banking, etc. Where would we be without our mobile phones? Yeah? Clearly, it is impossible to deal with it all, except in general terms. However, my experience and journey has mostly been in the first, traditional category. This is the basis for my observations and conclusions. Errors and omissions all my own. Move on to the project planning and development continuum. As a society, we generally view assets and infrastructure in the form or operation of the completed asset. The road we drive on, the train we catch, the electricity from the power station we use, and so forth. In fact, of course, all items of infrastructure are the culmination of often long and extended planning and communication and political decision-making processes. In addition, the asset will have a long lifetime, generally in engineering terms, specified to be 100 years or plus or minus, but in fact likely to be in place for far longer. The Roman aqueducts have been around for thousands of years. Bridges and railways built by Brunel are still in use after 150 years. The Roman aqueduct, an enduring symbol, indeed, of infrastructure. As an observation, the critical and strategic value of the effective delivery of infrastructure was well demonstrated by the Roman Empire. The skills of the Roman engineers in constructing roads and bridges to enable their rapid conquests, and the aqueducts for water supply to support the new territories administered, were undoubtedly fundamental to the growth of that empire 2,000 years ago. However, I think it's important to think of the planning and development of infrastructure as part of a continuum or ongoing infinite cycle, as illustrated on the infrastructure continuum slide that I'll put up there above. And you'll see that's divided into two halves, but interconnected: government and society, or society and government, the community, and the infrastructure, the engineer, the providers and doers. And those two processes are totally interrelated, and we'll go through a little bit of that as we go on. The point I want to emphasise here is the interaction of society and government and the community with the planning, design and delivery of infrastructure. Infrastructure does not emerge from a vacuum. It is a development and delivery as part of a constant, never-ending process. The sequence and development process and project descriptions may vary in different countries and government contexts, but the essence is shown in that cycle. The development of public and even that of large-scale private infrastructure is inevitably part of that political process and planning development cycle. It is affected by the political environment and changing priorities of governments, reflecting public perception and choices of the day. Ultimately, the projects to be delivered will usually be a public asset. Even if some project formulations, such as PPPs, they are privately funded and operated for a period. In the preparation of alternatives, the planning team, usually led by engineers, forgive me, in my biased view, the best to lead the teams, as they are trained to generally bring structure and rigour to the process, but with a wide variety of disciplines in the team, along with the design and delivery engineers, social, economic, financing, environmental and other specialist technical advisors who must, and I assure you do, respond to government and social feedback and imperatives. The differing values, demands and needs and so forth are not always easy to reconcile. Inevitably, there will be those in the public who are for and against a particular proposal. In principle and in government policy, the benefits, physical, economic and social, must and should outweigh the costs and negative impacts. However, attempting to reconcile the physical and economic aspects with the social and non-quantitative elements is a challenge for all parties. And the balance is usually still subject to debate even as the projects progress. In Australia, this process can be further complicated between the offering differing requirements and political imperatives of local governments, states and the federal government. From my perspective, from across the ditch, living in Brisbane as I do these days, in respect of trying to achieve that necessary balance between the physical and the subjective, the Living Standards Framework and Assessment Dashboard developed by New Zealand Treasury appears to be a positive attempt to bring together a summary of the social well-being of various elements of society and to assess intergenerational impacts, which can be used as an input to the decision process. Set together with the physical and economic drivers, this framework should guide both general policy making and also the choices between infrastructure alternatives being considered and to be implemented. The other critical part of the decision framework is the legislation within which government and private developers operate. In New Zealand, you have 3 acts which are relevant, possibly others also, but 3 key ones: the Resource Management Act, the Land Transport Management Act and the Local Government Act. Altogether quite a complex environment to navigate and which can create conflicts between overlapping responsibilities. The only legislation with which I have any recent experience is the RMA. I recognise that the RMA makes a great effort to ensure environmental impacts and issues are properly considered and evaluated, and to give the community and all affected interests a real voice in the outcomes of what is being proposed in a development project. It is an avenue for individual, environmental and cultural sensitivities to be expressed. And on that front, I recently, for a period, managed the start-up of the Pūhoi to Warkworth project just north of Auckland, and we had a great deal of interaction with the local iwi, who had formed themselves into an effective team that the project worked closely with, and they brought together 6 iwi or 5 iwi and other local hapu to work together under a common banner, which was very good. However, it can and does also take a great deal of time to work through and imposes a plethora of conditions which can add substantial time and cost to a project. It creates quite a rigid framework for an infrastructure developer to work within. It also, by the way, creates plenty of work for planners and the lawyers involved in the process. The overall balance of costs and benefits and outcomes, of course, are for society and government to judge. How, as an interested infrastructure deliverer, I do think some review and simplification of the RMA and in context with other relevant acts could benefit the decision process, reducing cost and time without losing the environmental and social equity sought. I understand the government has indeed appointed a panel of experts to advise on possible reforms of the RMA and other key acts. It will be important, though, not only to review both the laws themselves, but also the wider institutional framework and funding systems essential to the delivery of national infrastructure objectives. I'm sure the outcome of such a review will be a key input to the task of the newly created Infrastructure Commission, which I understand really came into being just in the last couple of months. The delivery part of the life cycle, the left-hand side, traditionally inhabited by engineers. Traditionally, the task was just to design, as important as this is and will continue to be, and build and leave the initial planning, financing, operation and maintenance to others. That's no longer the case. Structuring of alternatives, not just design alternatives, but everything from do nothing to different means or technologies of solving or meeting issues, both structural and non-structural, to achieve the outcome must be and are being explored. Design now must be for whole of life in cost and operational terms. The trade-off between initial cost and time versus what might be more expensive but provide better ongoing service is an essential part of that process. Finally, a process for reviewing and determining what has been delivered over time, what works and what doesn't work, to provide feedback to society and the government is essential. Again, I understand the new Infrastructure Commission will, as part of its task, carry out an audit of the state of New Zealand's infrastructure. Such reviews will be a vital task prior to determining future infrastructure priorities. If a project is privately financed, the financial model demands more complete life cycle assessment anyway, to enable the highest efficiency, lowest cost outcome to be achieved. Such analysis must also help to determine whether or not the project is viable on a standalone basis, what form of government support it will need, and in what form and by how much. Of course, this type of life cycle evaluation is and must be inherent in the decision processes. All government agencies, project developers and investors will follow these days. Infrastructure is an essential basis for the economic well-being and growth of a country and its society. Planned and delivered well, it enables communities to function safely and enhances the well-being of its citizens. It allows and improves the ability of private companies and industry to produce and distribute goods more efficiently, and along with government, to provide more effective services to allow the people to go about their daily lives securely. Providing for the safety of the community is an essential part of any and all government responsibilities and is a fundamental goal of all major infrastructure projects, particularly those involving the mobility of people. This is equally true whether the project is for road, air or sea travel. That slide up there now is a couple of views of the slowly emerging Puhoi to Work With project. You can see it's being driven through some pretty rugged country, across along the ridges, and this viaduct has been built across the Puhoi River, Kahu Inlet, sorry, and a very culturally sensitive area. A primary focus in New Zealand, of course, must be to improve both the direct safety of our motorists and travellers generally, and to promote alternate modes via far more efficient and safe public transport, reducing road demand. Bluntly, New Zealand has a very poor road safety record, which should be top of mind for governments in determining investment priorities in this sector. As vehicles get faster and safer in themselves, this must be matched by the quality of the roads provided for their increasing use. I fully understand the claims of some that better, higher capacity roads simply create more traffic demand and hence we shouldn't build more roads. I respectfully, but partly, disagree. In today's world, better roads are an essential to improving mobility, transport efficiency, safety and economic growth. However, of course, better mobility must also be part of a balanced system, using a variety of transport means, with rail, light rail and buses key elements of any city or national planning. The progression to electric and autonomous vehicles adds another dimension to be addressed to allow their benefits to be captured and realised. Another aspect of enhancing community safety is in the creation of greater resilience. And this is a word you'll hear a lot, I think, in the coming decade, the resilience of our infrastructure and buildings for communities against natural disasters, such as floods, earthquakes and coastal protection systems, to cope with rising sea levels as a consequence of global warming. This is a slide of a barrier created in the Netherlands, I believe. I think it's quite interesting because it's there trying to control the movement of water to prevent inland flooding, but also you'll notice that it's got wind power, as there are a lot of wind power along that coast, providing the energy for its operation. With its location on the Ring of Fire and majority coastal population, these are existential threats of great priority for all of New Zealand at both national and local government level. I know this is very well understood here in Christchurch, still recovering from the earthquakes of 2010-11, but having delivered added resilience in its urban systems rebuild. Still, New Zealand, amongst many countries, remains vulnerable to rising sea levels as a current, complex and enormous challenge. Consider what the impact would be of a rise of just 50 centimetres, or worse, 1 metre or more in sea levels, well within the relatively short-term scenarios being considered worldwide and here in Christchurch and New Zealand. And I'm sure you've all seen the reports on the rising levels in Venice and just how much disaster and the costs of trying to ameliorate those impacts. I'm not trying to be alarmist, but the scale of the challenge is clearly a substantial one for government and the engineering community. I'm sure there are mitigants. After all, as on that slide, Holland has been successfully and continuously battling the sea for generations. But it's a constant problem. But these must be addressed both in the policy area and in the planning environment, as well as with physical infrastructure. Sustainability and the impact of climate change and how it is to be dealt with in New Zealand and globally is, as I said above, a massive threat and a challenge for us all. Having trained in environmental and water resources planning, I remain acutely aware of the challenges that must be met in achieving an appropriate balance between the impacts of our engineering projects on the natural environment and our increasingly fragile ecosystems. Society's values continue to evolve, and trade-offs that were acceptable in previous decades may not be accepted today. As an example, much of New Zealand's hydropower system, which underlies the high percentage of renewable energy that New Zealand enjoys and is much envied by other countries, and on which much of the economic well-being of this country depends, might not be able to be developed today under current environmental sensitivities and priorities. I'm not trying to judge today's decision climate as better or worse than yesterday's. They reflect the times, but hard choices and their consequences cannot be avoided, particularly by the engineers and planners working in the infrastructure sector. One cannot just walk away and say, it's all too hard. Do nothing can have just as much an impact as going ahead with a project. It's just a different outcome and maybe a worse outcome. I can say, though, from personal involvement in at least 10 major projects, when I say major, over $1 billion, and many smaller ones, that seeking to balance or ameliorate negative environmental impacts and indeed improve project outcomes is a major task of the development team, taken very seriously and any downside continually challenged on an ongoing basis. Naturally, engineers are part of society and share similar concerns, despite some views to the contrary. The positive impacts of both delivery and operation of infrastructure are both well known and widely analysed. The creation of jobs and the immediate impact of project spending on the local and, for major projects, national economies have been well documented. From my personal observations at a direct project level, the multiplier effect of the spending by the project and delivery team in the local community during construction is quite immediate and substantial, ranging from such simple items as increasing numbers of of housing rentals, purchases from local businesses, of administrative supplies and services, small plant and equipment rental, procurement of materials, transport services, specialist plant, local spending by families at the shops, attending schools, etc. And one phenomena, given the coffee culture in New Zealand and Australia, is the importance of our local coffee shops or mobile facilities which come around the sites. I can assure you they get very, very well attended by the workers on our projects these days. In the longer term, the improved mobility impact of a new tunnel or highway or metro or light rail system on reducing the costs of congestion, shorter and more secure travel times, increased safety of motorists and travellers generally are also being very demonstrable. This is just being commissioned right now. If any of you have been in Sydney recently, down George Street, these are these brand new light rail vehicles that will go from Circular Quay all the way out up Anzac Avenue. And they're quite long machines, no overhead wires. You'll notice through the city they're actually powered by underground. They've got pads they power to. So very attractive and easily used system. The broader positive impacts of both creating new infrastructure and upgrading and improving operating existing assets on national and regional economies have been extensively studied and documented. The primary measures quoted are the improvement in overall economic output and increase in employment. Economic output is increased by the additional spending on infrastructure, leading to the immediate stimulus as before. It generates on demand for a variety of products and services. In the longer term, the increased productivity is generated from the more efficient production and delivery of goods and services, leading to greater economic growth. The amount or degree of such benefits varies from country to country, the type of infrastructure delivered, for example, physical capital versus social capital, for example, and the type of financing employed. However, in all cases I have studied or am aware of, such spending has had a positive, substantial economic impact. Indeed, in Australia at present, trying to stimulate the economy is a priority. The federal government has just committed an additional $100 billion for infrastructure development to provide further stimulus to the national economy. And yet it's been criticised for not doing enough. And the government, in addition, just in the last week, announced an acceleration of the early stages of that capital injection across every state in Australia. So they certainly believe, and I believe, the economic stimulus of infrastructure is demonstrated. Finally, the next topic was financing the project pipeline. Infrastructure, particularly major projects, don't come without the need for massive amounts of capital, both for new assets and ongoing operations. Ongoing operations, maintenance, capital refurbishment. Noting that we obviously often focus on the headline capital cost of infrastructure, but the life cycle spending on operations and maintenance and financing can also be a very large component of overall costs. And just to give you an example, I was responsible for the delivery of the airport link in Brisbane. The capital cost of that project was $4.3 billion, which we delivered in 47.5 months, so spending at about $90 million a month. But the total financing cost for that project was $5.5 billion, so $1.3 billion was in financing costs, in providing for the future maintenance and operations and so on. So, as I say, you can see that a large part of the cost is not just in the physical build. In New Zealand, Treasury forecast that additional, I was just informed this morning, I said 129, but it's now 138 billion, excluding social infrastructure, will be required over the next 10 years. 6 billion, actually now 21 billion, has been assessed as being in the immediate planning approval process of key government departments. In Australia, many billions have already been invested in the last few decades, and as above, much more is in the pipeline. In the US, figures in the trillions are suggested just to keep current and ageing infrastructure, a lot of which is transport related, in effective working level, not including the pressing need for new assets. Such major spending must inevitably come from government or with government support. Hence, by definition, spending on infrastructure has a political dimension, and political priorities influence the choices made. In simple terms, I know it's far more complex than I understand anyway, or can set out here, governments have the choice of spending within current budgets, balanced or otherwise, or borrowing deficit financing to facilitate or accelerate economic growth. There are economic arguments presented that deficit financing can provide a greater stimulus for the growth in GDP, but I'm not skilled enough in economics to make such an analysis or reach such conclusions. However, reaching an appropriate level of spending is a social and political choice, or balance of priorities. There are strong arguments, not confined to New Zealand, certainly also in Australia and other Western nations, that greater levels of spending on infrastructure are needed to maintain our economic growth, depending on the standard of living. In Australia, depending on the definition of infrastructure used, it is claimed that infrastructure spending gets up to around 3.5% of GDP. Over recent decades, infrastructure as a spending of GDP in a number of countries has declined. I assume from Treasury forecasts above that I just gave you, that if New Zealand has been lagging in its infrastructure investment to date, the objective must be to increase that spending, a positive step. And by the way, I got some figures this morning that said over the last 10 years, New Zealand, on average, excluding social infrastructure, has been spending around 3 to 3.2% on infrastructure as a percentage of GDP. It reached about 4% during the Christchurch rebuild, and the forward forecasts on those numbers that I gave you would push it back up over 4%, so that's a positive sign. I thought I'd put the Port of Auckland as just a background slide because obviously it's a topic of some discussion right this very minute as to whether or not how the country should deal with the logistics chain in the northern part of the North Island between Tauranga or Mount Maunganui, Auckland and Whangarei. But ports are a very important and critical part of our infrastructure. It is critical that a sensible pipeline for such spending is developed. This is essential to allow the planning processes to operate in a timely fashion and to give the industry, construction resources, material suppliers, financiers, opportunity to develop the capacity needed to deliver the work efficiently and cost effectively. I do make a note of caution. My construction partners wouldn't agree with me, but the pipeline should be carefully established to balance and stretch, but not to overtax the capacity available, even allowing for growth from firms and assets which will and are coming to New Zealand from overseas. Otherwise costs will increase and delays will occur as resources are constrained. I learned today, which I hadn't known before, that there is a move to integrate the infrastructure markets of Australia and New Zealand, and that can only be a good thing. There are, of course, other sources of finance available to governments to support the growth of infrastructure. The privately funded PPP, or as we used to call them, BOOT projects, build, own, operate and transfer projects, are a much larger component of infrastructure development in Australia than they are in New Zealand. Any of you who have been in the major state capitals in Sydney, Melbourne, Brisbane, even Adelaide and Perth now will have seen that sort of work that's going on, and a great deal of that is privately funded. I strongly believe that a greater focus in New Zealand on the use of private funding of PPPs for economic and transport infrastructure would be of substantial benefit to increase the rate of delivery of infrastructure, that really important infrastructure here. West of Brisbane, they've made a connection up through the dividing range called the Toowoomba Second Range Crossing, and I put that bridge up there because it's not a particularly grand or unique bridge. It's a very nice one, but if you have a look at it, it's kind of got the same form as the Roman aqueduct, so some things never change. There are, of course, ready sources of finances available from the very substantial established banking and investment finances houses, as well as the massive superannuation funds. In Australia in 2018, the superannuation funds had $2.7 trillion in investment. I believe that's climbed to 2.9 billion as of last year. Trillion, sorry. And similarly, there's a growing capacity and interest in New Zealand through the New Zealand Super. These funds are ideally placed to finance infrastructure with longer-term, moderate to low risk and reasonable returns available, meeting their criteria to invest. In the past, some funds were cautious about the costs and risks of taking front-end roles because they didn't want to risk their money, their super money, in their home territory, but now they are large enough and are looking for opportunities to invest in their home markets. Noting as a real positive, I think, and I'm not sure whether they will succeed in their venture, an initiative by New Zealand Infra, which is a combination of New Zealand Super and CDPQ, a large Canadian pension fund, to front end the Auckland Light Rail project, and I think that's a really positive step. I do not accept that it is government's sole prerogative or responsibility to fund infrastructure, and that the private finances should not be allowed to make a profit from providing essential services via infrastructure financing. In fact, much of such funding is actually coming from the community's own savings via the super funds. Hence, in a way, the community is or can participate in its own development. Government resources are limited and borrowing limits are constrained and subject to the scrutiny of international credit rating agencies. It is often noted government can borrow more cheaply than the private sector, which is true. However, private funding can allow projects to proceed much more quickly than if left solely to the state. And there is equity in the funding, as it is recouped over time, transferring some of the obligations to the future generations who will benefit from the services, acknowledging that government borrowing has some of the same transfer characteristics. The other benefit of private funding is that the competition engendered often leads to greater innovation in the solutions delivered. I have direct experience of this, again, referring to my project at the airport link in Brisbane. In trying to win that project, because we'd lost the previous one, our engineers went to great lengths to look at the design and to make it more efficient, and we ended up virtually completely not changing the design, putting a lot more of the project underground, putting the interchanges underground, which improved both the safety of the operation and it improved or reduced the impact on the community above. And that came out of that competitive design process. I also believe the principle of user pays inherent in toll roads and public transport is important. In appropriate circumstances, if we benefit, why shouldn't we be prepared to pay? And I know there are arguments, and we discussed it this afternoon, that this is a bit unequal because wealthier or the middle class can afford to pay those things better than people on lower incomes, and so it's retrogressive in that respect. But I think in appropriate situations it is still appropriate. Yet another funding issue relates to the challenges of revenue raising for roading projects. With the ever-increasing fuel efficiency of petrol and diesel vehicles and the growth of electrical vehicles, who don't use fuel of course, fuel taxes have become far less effective as a means of providing road funding, and different forms of road user charging will need to be considered and developed if we're to provide equity in delivering those services. And by the way, California and Oregon and the United States both are really facing up to this challenge and looking as to how they would, whether they measure vehicle kilometres or capacity of vehicles or what they're going to do. They're all struggling with how to resolve this problem. However, the key to attracting private funding, both equity and debt, is that a reasonable balance of risk between the private or non-government funder and the state or government entity is reached. In my view, to date, the transfer of risk has become overly demanding on the private sector and the construction industry. This has the effect of unnecessarily increasing cost, both in the contingency provisions made and the return sought. It is a misapprehension that by transferring as much risk as possible to the private or non-governmental sector, this is necessarily good for government. And by the way, this is an area I point the finger at the legal profession. They believe that their responsibility to a client is to reduce the risk as opposed to assisting the client and the deliverer to reach an appropriate balance of risk, which I think is fundamental. Given the scale of many PPP projects, if things do go wrong, and even if the government has little or no financial risk exposure, government and its reputation will inevitably be impacted. As an aside, I would also note that despite complaints to the contrary, that in Australia, where several recent demand-driven, i.e. tolled road tunnel PPPs have financially failed, one of them a project that I delivered, in fact the private sector equity and debt providers have taken the full loss. No input at all on those projects from government, while the asset has continued to provide its promised benefits to both government and the community. This is a slide of a tunnel boring machine coming out next to the previously driven tunnel on Crossrail in London. The reason I put it up there is again because it's apposite to the fact that you're about to start the work on City Rail Link in Auckland, which will be twin tunnels just like that. I don't know whether the diameters are the same. They look a little larger, I think, than the ones that will be in Auckland, but the principle is the same. So I might turn now to the role of engineers. In the built infrastructure in which I've spent my career, and where the primary options are usually driven by engineering considerations, I believe the leadership role of engineers is fundamental. There are several factors behind this conclusion. Engineers are taught and trained to be analytical and thorough in the consideration of alternatives, particularly the engineering integrity of various design proposals, to plan and work to a program of activities, usually against tight deadlines, to assemble the range of skills needed and to provide the management of that team, assessing and dealing with the risks both during design and construction, while meeting very demanding cost and financial targets. I don't claim that other professionals are unable to perform leadership roles on major physical infrastructure projects, but where the underlying outcome relies upon the engineering integrity, and who knows that better than Christchurch, of the project and the structure, society demands confidence that safety and operational integrity will be guaranteed. So the central role of engineers, I believe, is clear. But, as I said earlier, engineers are, of course, also part of society and subject to all the same range of political, social and environmental issues and views as the wider community. We don't work in a vacuum, isolated in our projects. Hence, the challenge in leading the development of a project which can and will have a major impact on people and the region or country, economically and environmentally, is very significant. As noted, reaching a balance between the economic, social and environmental drivers is complex. However, decisions must be made, often under real-time pressure, especially when responding to an emerging situation or crisis. Decisions cannot be sidestepped. In real time, the do-nothing option may not exist. But engineers are fundamentally doers and have to act, albeit understanding that they will be scrutinised for their decisions post facto. So be it. We have to rely upon our judgment. The range of skills needed by project managers of major projects is extremely wide. It is not enough these days just to be technically skilled. A focus on safety and management systems must be at the core of all projects. Mostly, environmental factors will be key elements, and understanding this science is important. Social awareness and the ability to manage the interpersonal dynamics of large teams is necessary and not always found. Also critically, without being a bush lawyer, I've been accused of that in the past, knowledge of the applicable laws, the interplay between the construction and financing documentation, and being able to navigate this increasingly complex space is essential. It sounds complex, it is, but with multidisciplinary training, which is part of engineering education these days, and an open approach to learning on the job, one survives. In summary, to quote the Director International of the Institute of Public Works Engineers in Australasia, engineers have a significant role today in creating more sustainable cities into the future. Our niche is being able to develop creative solutions for the challenges of tomorrow. If I may be indulged, I'll just finish off with a few personal reflections and challenges. I have been incredibly lucky in my career of over 47 years since completing my university education. At various key moments, I had the good fortune to have advisors who helped me navigate important decisions. Professor Frank Henderson, a world leader in the science of hydraulics at this very institution, who encouraged me to widen my horizons to study overseas. Prof. Ray K. Lindsley at Stanford, also a world-renowned expert in hydrology and water resources planning, who led me out of pure engineering and into the social and political sciences critical to multidisciplinary project assessment and delivery. It is worth noting, though, and with the NZIE representative here, that in the days of the IPENs, when I came back and went for my engineering registration and took them through some of the things I'd done in environmental and social work in the States, they asked me whether I was still an engineer. Bill Duncan, as I talked about above, my late brother John, who actually was the one who spotted the opportunity and sent me a clipping from the paper about an opportunity to manage the building of the first geothermal power plant in Indonesia, and knew I was looking beyond just a government career. And that's Kamojang. That's the first stage. It's a much bigger project now, and it's surrounded by three other projects on the same field, and over the mountain another 3 or 4. Geothermal has become a very large part of our world these days. But that little 30 megawatt station, which was New Zealand's largest aid project at that time, $50 million US, I always knew when it was operating because it was right at the end of the transmission line, and it acted like a capacitor. And so when it went down, the lights in Bandung, where we lived, about 50 kilometres away, used to flicker. So I'd ring it on the phone and say, "What's going on?" "The lights are flickering." And they would tell me what was going on. Kamojang gave me my first standalone project management task, which was fantastic. Malcolm McConnell is another person from McConnell Dow who gave me my first opportunity in general management, and Martin Albrecht, the former CEO of TEAS, who pushed me towards the very large multidisciplinary PPP projects we've been talking about and that have kept me busy for the last 24 years or so. Of course, there are many others. However, the point is we must listen to those who know more or have wider experience than we do, and as above, grab the chance and just go for it. I do a bit of mentoring of younger engineers who often come to career crossroads and whether they should be a little conservative or whether they should step over the cliff. And my invariable advice to them is step over the cliff, get on with it. Even if it doesn't quite work out the way you want, you'll have learnt such a lot, you'll be better in what you were doing anyway. So go for it, that's my motto. What are the learnings I've had? A great deal, obviously. I seriously believe that any day of learning something new is a good day. And I was delighted to hear my good friend Barry went back to do a bachelor's degree later in his career, and other friends of mine have gone back and done PhDs late. An engineer who worked for me on Airport Link managed to do his PhD while he was my chief engineer. I reckon he doubled our paper use because he wrote so many papers and things. So learning is a great thing. Engineering has provided me with the learning discipline needed to work in and lead teams to develop projects which I believe have largely been of substantial benefit to the communities and cities or regions affected. There are always negatives and positives, planned and unplanned. The orchards, you'll remember the grief over the flooding of the apricot and cherry orchards in the Clyde Gorge. But lo and behold, with the water available, they were effectively replaced by the Central Otago wine industry. I'd like to say that was planned, but little did we know. Anyhow, one small connection to that project, I was recently, or last year, at Fulton Road near Bannockburn, and they pulled out the soil plans that they'd used in planning their planting. And those soil plans were the ones we developed for that project. So they had an ongoing benefit. Also, as in Brisbane, on Airport Link, there was a short-term impact and real disruption of local urban communities from a major transport work like that project. But they mostly lead to long-term positives on the community and industry from improved mobility and accessibility. Another small anecdote on that project, there was a period where, without going into too much detail, there was a large excavation cavern underground which had to be completed to allow TBMs to come through at a certain program, and they weren't getting done fast enough. So the loose solution was to drop a 30-metre shaft down into that site to let us put some road headers down so that they could pre-excavate. So we had to build a shaft in what was a bit of vacant land, but which the community had taken it upon themselves as a local park, or it was a local recreational area. So there was an enormous amount of community angst. We went through a lot of planning. And I, for the first and only time in my life, was featured on a public billboard. The community, who believed I was earning a fortune in running the project, had a billboard that said to the effect, "Ray Wilson gets a fortune, Wooloowin gets the shaft." It is vital to appreciate the critical difference or importance of communication and listening to all stakeholders affected by a piece of infrastructure. Almost invariably, a lack of understanding leads to concern and resistance to change. While not all communication leads to acceptance, the very effort of at least talking to people is essential to more successfully managing the work. When we were doing Lane Cove Tunnel in Sydney, there was a lot of angst with people where we were going underneath houses. We assembled the local community and took them down into the tunnel so they could see what we were doing. Actually, it was... And from that day onwards, even though they didn't want to be tunnelling underneath them, they knew what was there and they accepted it. Or at least they didn't create so much fuss. And of course, the fundamental need for teamwork. As project managers, we tend to talk about, and I've done it myself tonight, our or my project. Actually, we are just part of, maybe the leader and perhaps the spokesperson of the team, but for sure, Every role has its place and importance. The team leader will get nowhere without the team, the hard work and commitment of his or her engineers, supervisors, labourers, accountants, cost planners, procurement officers, clerks, etc. and so forth. And these very large projects are quite massive in terms of the amount of support people you have. We had a full legal department, we had a full accounting department, a cost control department, and so on, all as well as design and everything else. We employed 4,000 people at peak on that project. Future challenges, just to finish off. In my estimation, one of the largest infrastructure challenges facing governments, the community as a whole, and the engineering community is that of climate change, with its ever-increasing impact on weather patterns, rising sea levels, ecological systems on land and on the sea. Clearly, there must be policy and legislative changes or adjustments at both individual government and international forums, now and impacting over the longer term. However, I also believe physical infrastructure interventions, like the one in Holland and other places, particularly in the shorter term in coastal regions and urban structures, the resilience of urban structures, and in achieving carbon neutral energy supply is fundamental. In Singapore, they've now brought in planning legislation that ensures that the ground floor of all new buildings can absorb water, can take a flood or a tide, because they want to ensure that the integrity of those communities are protected for the future. That's planning for the future. The financing task, it's worth noting that it is forecast that 65% of the world's population, I've seen as high as 70, will live in cities by 2050. 65% of the world's population in cities by 2050. This simply reinforces the requirement and challenge to develop resilient and energy-efficient cities and buildings. The second one, the financing task. Just to keep existing infrastructure in proper and safe working condition, plus new and replacement capital works is, as mentioned earlier, an enormous one. It requires both government and the private sector to be heavily involved and to work closely together. Priorities may need to be reassessed. However, I do believe a far greater role for the enormous savings now available in superannuation funds, your savings, should be a greater part of meeting this challenge, and I stress that for New Zealand. Finally, despite being an older, white, male fogey, I am acutely aware that we need to do far better in mobilising the full range of talent available to us by attracting a much higher percentage of women, ethnic and others from minorities into the engineering profession. I know there has been substantial progress in this regard, but we need to do more. We're basically not using half the resources available to us. No wonder we're not getting there. A challenge generally, but also the educational institutions, such as this one where we are tonight. My best regards to you all. Cheers.